Hello, welcome. Today we are looking at connected particles, and that is under A-level mechanics. So we have a simple question here to answer, and it reads: a particle of mass 6 kilograms rests on a rough horizontal table. The table is connected to another particle. The particle is connected to another particle of mass 4 kilograms by a light inextensible string passing over a smooth fixed pulley. The 4 kilogram mass hangs freely. The coefficient of friction between the block and between the table and the block is 0.4. If the system is released from rest, find the acceleration of the system, the tension in the string, the distance the 4 kilogram particle covers after moving for 3 seconds. And here is our illustration. So the illustration, so here we have our mass, which is a particle of 6 kilograms. Then it is connected to the 4 kilogram mass particle by an extensible string. So this string here, which has a tension force in it. So the 4 kilogram mass will have a weight of 4g. The 6 kilogram mass will have a weight of 6g. And since the surface is rough, we shall have friction. So this is the friction force that is opposing the motion, and then R is the normal reaction. So after indicating all these forces, we can now begin to resolve. So considering the 6 kilogram mass, the resultant force on it, since the body this was hanging freely, so it will tend to pull this 6 kilogram mass. So the movement will be towards the 4 kilogram mass. So the resultant force on the 6 kilogram mass will be T minus F, and we shall equate that to 6A using Newton's second law of motion. But our F is equal to mu R, and from our diagram, the mu R is 6G, so we shall have T minus mu times 6G equaling to MA. So we can rearrange it and write that as our equation 1. Then we go and consider the 4 kilogram mass. So considering the 4 kilogram mass, our resultant force will be 4g minus t, and that will be equal to 4a, still according to Newton's second law of motion. So we can add the equation 1 and 2, since we have a negative here and a positive t. So when we add, the t's will disappear, and then we shall have t minus 6g mu plus 4g minus t is equal to 6a plus 4a. So finally we shall have 4g minus 6 times the value of mu, which was 0.4. G is equal to 10A. So 6 times 0.4 gives us 2.4. So 6 minus 2.4G is equal to 10A, and 4 minus 2.4 gives us 1.6. So we shall have 1.6G is equal to 10A. So dividing the A, we shall have our A as 1.6 over 10G. So which we can write as 4 over 25 G meters per second squared. So that will be our acceleration. So moving forward, so when we get equation 2, which was 4g minus t equaling to 4a, so and we substitute the value of the acceleration, we shall be in position to get the tension in the string. So we can rearrange and have t equaling to 4g minus 4a. So we are going to substitute for the value of a, which was 4 over 25g. So when we substitute, we shall have 4 times 4, which gives us 16. So we shall have 4g minus 16 over 25g. and when you subtract 4 minus 16 over 25, it will give us 84 over 25 G Newton. So that will be the value of the tension. Then looking at the distance, the 4 kilogram mass covers after 3 seconds. So our S is 1 Wilkaya, which is distance. T is equal to 3 seconds. Initial velocity was 0 since it was from rest, and then our acceleration is 4 over 25 G. So we are going to substitute in this equation of motion, and then we shall have S equaling to 0 times 3 plus a half times acceleration, which is 4 over 25 G times 3 squared. So the first one will give us 0, 3 squared gives us 9, then by 2 here, and here it will be 2 over 25 times 9, and that will give us 18 over 25 G meters. So that will be our value of acceleration.